In this video, let us solve for x given 5 raised to power x times 25 raised to power x is equal to 100. So we have 5 raised to power x times 25 raised to power x. 25 here is 5 raised to power 2. Then raised to power x to give us 100. By law of indices, a raised to power m raised to power n will give us a raised to power m times n. This will then give us 5 raised to power x times 5 raised to power 2 times x is 2x is equal to 100. There are so many things I can do from this point, but let us combine these powers together. Since the bases are the same, I'll use this law of indices. A raised to power m times a raised to power n is equal to a raised to power m plus n. Therefore, this becomes 5 raised to power x plus 2x is equal to 100. 5 raised to power 3x is equal to 100. This is an exponential problem. Let us take the logarithm of both sides of this equation. So we have log 5 raised to power 3x is equal to log 100. This expression here is of the form log a raised to power m, and by law of logarithm, this can also be expressed as m times log a. Therefore, this becomes 3x times log 5 is equal to log 100. We can now divide both sides by log 5. So log 5 cancels log 5 here. Then we have 3x is equal to log 100 divided by log 5. This can also be written as 3x is equal to log 100 here is 25 times 4, then divided by log 5. At this point, let us separate this into two individual logarithms. To do that, I'll apply this law of logarithm. Log a times b will give us log a plus log b. So 3x is equal to log 25 plus log 4, then divided by log 5. So 3x is equal to log 25 divided by log 5 plus log 4 divided by log 5. We have 3x is equal to log 25 is 5 raised to power 2, then divided by log 5, then plus log 4 is 2 raised to power 2, then divided by log 5. We will express this as 3x is equal to 2 log 5 divided by log 5 plus 2 log 2 divided by log 5. So that log 5 cancels log 5 here. Then we have 3x is equal to 2 plus 2 times log 2 divided by log 5. Let us work on this expression. By law of logarithm, log a divided by log b will give us log a base b. Therefore, 3x will give us 2 plus 2. This will now be log 2 base 5. And then we will now divide both sides by 3. So that 3 cancels 3 here. Then we have x is equal to 2 over 3 plus 2 over 3 log 5 log 2 base 5, which will now be our final answer to this problem. Now we got x is this. Let us check to confirm that this is correct. The problem given was 5 raised to power x times 25 raised to power x is equal to 100. We're going to substitute this in place of x, but before then we already simplified this to 5 raised to power 3x is equal to 100. Not much has been done, so we can still use this to save time. This would then imply 5 raised to power 3, then into brackets all of this. So we have 2 over 3 plus 2 over 3 log 2 base 5 is equal to 100. If we open up this bracket, this 3 will cancel all of this. Then we have 5 raised to power 2 plus 2 log 2 base 5 to give us 100. Then let us open up or separate these powers. To do that, I'll use this law of indices. A raised to power m plus n is equal to a raised to power m times a raised to power n. So we would have 5 raised to power 2 times 5 raised to power, this will be 2 log 2 base 5 is equal to 100. Then this is 25 times, if this goes all the way here, this will be 5 raised to power log 2 raised to power 2 base 5 is equal to 100. So we have 25 times 5 raised to power log 4 base 5 is equal to 100. Now let us work on this expression. By law of logarithm, a raised to power log p base a will give us p, as long as these bases are the same. So as long as these bases are the same, this must be 4. Therefore, we have 25 now times 4 to give us 100. And 25 times 4 is 100. So we have 100 is equal to 100. The left-hand side is equal to the right-hand side, confirming that our solution for x is perfectly correct. Thanks for watching. Please like and share. And remember to subscribe to my channel. And I'll see you in my next video. Bye.